Fractals have been researched for many years, with discoveries such as the Cantor set, Koch snowflake, and the most well-known Mandelbrot set. People have been interested in these fractals because of their nature, which in itself is self-recursion that tends towards infinity, along with the idea that these mathematical sets have links with other areas, such as tree growth. In more recent years, they have been incorporated into large VFX productions, with the most popular being Doctor Strange, where they were used to manipulate objects and create a psychedelic effect. It has also been used to create large alien worlds with the likes of Big Hero 6 and Guardians of the Galaxy Volume 2. However, apart from a paper that demonstrates manipulating entire meshes with fractals, there has been no bespoke use of fractals on hero objects. This is where my project starts. My aim was to create a tool that produced fractal objects, along with the ability to change parameters like the shape and speed, and then integrate them onto meshes, creating a new way to use fractal geometry. By using the Mandelbrot set as a guide and volumes in Houdini, I created the Mandelbulb with phase shift animation, with its overall shape being controlled by a value n, which represents the order of the fractal. As you increase the value of n, you start to notice a recurring pattern that is also found in the Mandelbrot set, and so this can now be classed as fractal geometry. From here you can also edit elements like the theta or phi parameters to create more interesting results, but at the cost of it no longer being classed as a Mandelbrot fractal. Once we have our 3D fractal, I scatter points onto a predefined target mesh, which can be any OBJ, FBX, Alembic, or even pre-made geometry in Houdini. This acts as a point of reference to instance the fractal shape onto with a correct orientation. Once the fractal has been given a location, I subtract the fractal from the target mesh using Boolean operations, pre-made within Houdini. This cuts into our target mesh but preserves the inner surface, which is the fractal. However, a problem with using such a high poly object such as a fractal are non-manifold errors due to the poly count, resulting in the target's mesh surface not being properly subtracted. To counter this problem, I find the remaining points by using the fractal as a bounding object and group them together. From there they are simply deleted and we achieve our goal. To ensure a clean mesh, the normals are reoriented and disconnected points are fused together. From these results, you can see that any variation of a Mandelbrot works with static meshes, in addition to it working with moving objects, such as the fractal moving through a mesh and the target mesh moving through either basic transformations or pre-made animation. The tool also has artistic capabilities, by being able to apply colours to each of the fractals, whilst retaining the target mesh's texture if needed. The same circumstances would apply if any shader or material were used instead of a diffuse colour like I have here. While my tool has areas for improvement, I believe it is a new and innovative way in how the VFX industry can use dynamic fractals for both effects as a character effect, where some people have described the idea as an infection or something deteriorating, or for modelling with the ability to now use booleans with millions of polygons and points. If I was able to take this project further, I would create a more suitable interface and improve current features. However, I mainly want to show, along with other work, how effective fractals are and what they can provide to the VFX industry.